All right, welcome. Thanks everybody for joining us today. My name is Chris Neidl. I'm the co-founder of Open Air and your host today. Welcome to This is CDR. Very excited about this episode. We have some old and very, very good friends rejoining us for a second time. Duncan Kariuki and Martin Freimüller from Octavia Carbon. Just one of the coolest carbon removal projects and companies we have on this planet. So excited to get some updates from them in a minute. Tank, my co-host, well, he might not be ready yet, but I'll bring him up in a second. But before we do that, I'm just going to give a little bit of a background for those who might be new to the program about This is CDR. This is CDR is brought most Tuesdays at 12 Eastern, and this is sort of our flagship webinar program in which we get to talk to amazing people like Martin and Duncan, but all sorts of movers and doers and thinkers in the carbon dioxide removal space. And at the end of today, I will tell you about some of the upcoming episodes we have over the next couple of weeks. Just to give you a little bit of a background quickly on the Open Air. Open Air has been around since 2018, which is hard to believe. And we are a all-volunteer network of CDR enthusiasts and advocates who get to work in a variety of different ways trying to advance carbon dioxide removal globally. There's some key areas that we focus on. This is a prime example of our education material. We do a number of webinars and other types of programs that are just meant to sort of raise awareness, support, understanding, and enthusiasm for carbon dioxide. Again, those are webinars, those are happy hours we do, in-person events, a whole bunch of different stuff. Very active on the advocacy front. Open Air members have been some of the principal drivers, particularly of state-level policy in support of carbon dioxide removal in the United States. In a couple of weeks, I'm actually going to do an episode on This is CDR of a survey of all the different pieces of state legislation that are now being introduced here in the United States. So I can give an overview as well as sort of a summary of how you can take part in it. Very exciting. We got many bills, 2 in California, 2 in New York, and a smattering of others in other places as well. And we also have a really interesting projects that we do on the citizen science sort of maker side. At some point soon, we will have one of those projects featured called Epiphyte, which is a miniature direct air capture device that actually traces its origins back to conversations and early guidance from Octavia, believe it or not, full circle, but is now just about finished the latest build at UT Austin, where I'm based. So we'll have that team on to talk about it and share the open source designs. So those of you who want to take part in this this community, Tank will drop a link to our Discord, kind of like Slack. You can come in there, meet other people, chat, and get connected to some of the projects that we work on. So with that, I'm going to go ahead and bring up my partner in crime, if his video is ready, Tank Chen, who will go ahead and introduce our excellent guest for today. Go ahead, Tank.
Hi, everyone. Tank here. I'm an Open Air volunteer based in Taiwan. Today, we're very excited to welcome Duncan and Martin on This is CDR. So some background on the two. Martin is the co-founder and CEO of Octavia, Africa's first direct air capture company. Under his leadership, Octavia Carbon is pioneering carbon removal solutions tailored to the unique conditions of Kenya's Reef Valley, leveraging its geothermal resources for efficient CO2 removal. Before founding Octavia Carbon, Martin worked at Delbert, where he focused on strategy and innovation in climate and development. Prior to the start of his professional journey, Martin received his honors BA/MA in Social and Political Studies and Management Studies from the University of Cambridge. Duncan is Octavia's co-founder and chief product officer, where he leads engineering strategy of the company's direct air capture technology and Octavia's engineering and project strategy, focusing primarily on integrating Octavia's technology with clean energy resources. Duncan holds a mechanical engineering degree from the University of Nairobi. Welcome, Martin, Duncan, whenever you're ready.
Thank you so much. It is an honor to have the privilege of coming back on this CDR to give an update. And we're super excited again. So we have been on this CDR before, episode 79. We're huge fans of the show. I think I've probably watched every single one of them. And it's an honor, I think it's where CDR goes to talk. So it's fantastic to be here. To talk about our first 2,000 hours in the field. So again, I think we've previously talked a lot about the potential for direct air capture broadly and specifically in Kenya as well. We'll recap some of that very quickly today. But really, this is meant to be a project update, very much focused on a few learnings, really in the spirit of DAC innovators like Cloudworks, who've sort of been open about their experience in the field, the challenges, the opportunities, the learnings, the exciting and the less exciting things. We want to really put out in the open for our space to learn together how to sort of bring low-cost direct air capture to the world. And we are very proud to have sort of come to this point in about 2.5 years from when this was still a crazy idea at a kitchen table, very much with the help of our friends at OpenAir and many others, having now the Global South's first direct air capture plant and 2,000 operational hours behind it. The slight caveat there is that is operational hours at the machine level. There's 4 machines in there, so the whole plant has sort of been operating for closer to 1,000 hours. But again, increasingly, we sort of have a few learnings that might be interesting to share for anyone interested in sort of how building DAC in Kenya looks like, and potentially there's some learnings for DAC beyond that too. So do a very quick recap of what we do as Octavia before we sort of really jump into a few sort of pictures as updates from our project, and then also just the learnings that are specifically on the sort of project and engineering side that Duncan will mostly lead on. Just thought I'd sort of touch on a very few high notes briefly about what we've done. So again, to date, we've sort of built the Global South's first DAC plant, and we've run it for about 2,000 hours again, as you sort of would have seen in the previous screen. We've sort of gotten there pretty quickly. And sort of have built it in sort of 2.5 years, which is, I think, very sort of rapid speed. That has also now received a carbon credit rating that's pretty decent from our friends at B0. We've got about 60 staff with about 40 engineers today. We've got 16 corporate buyers, give or take, and sort of 21 purchases across these. And 2 patents, one granted, one pending, and again, increasingly the operational hours to really back up that technical excellence as well. We're proud to be finalists for the X Prize, and also have gotten a good amount of attention from media, and hopefully both for us, but also into the world of carbon removal, specifically in Kenya, which is increasingly becoming an amazing CDR hub in direct air capture, yes, but also across other methods, everything from enhanced rock weathering to biochar to nature-based, etc. Quite proud to be leading the way in the Global South there. Very briefly, again, there's much more content on why Kenya is a great place for DAC in our previous presentation on this CDR. Very quickly, just hit a few high notes. Basically, the bottom line is that Kenya has ultra abundant renewable energy. If you want to run DAC, you need clean, firm power in absolute abundance. Otherwise, you are not taking the steps forward that direct air capture needs today, and you might not be learning in the right place to create those learnings. Kenya is that unique place that has excellent endowments across geothermal, solar, wind, and hydro. And crucially, that geothermal is also the sort of main engine behind our specific technological approach that Duncan will talk a bit more about in a second. Specifically, we do think a lot about utilizing geothermal heat, which has of course been demonstrated by our friends Cloudworks. I think we sort of have a quite unique approach to it that we would argue really optimizes for it in a number of ways. Alongside that geothermal, we do have a unique geology in Kenya to mineralize CO2, and we do have our partners, Seller Mineral Storage, who we store our CO2 with, and are sort of very proud to be working with them. Generally, we will sort of forward most questions about the geology to them, and then we'll be quite humble about not being geologists ourselves, but it is worth noting that Kenya has an excellent endowment for its geology to store CO2. We then know that the Global South ingenuity and talent is an integral part of bringing climate tech hardware down the cost curve, and again, that has been the case in solar and wind and batteries and EVs, and now increasingly we want to make it happen in direct air capture as well. That speed of iteration that DAC needs today really needs lots of brains and hands, and Kenya has the unique ability to give people a very decent lifestyle at a fraction of the cost and of making those iterations elsewhere. And finally, it's also something that we're quite proud to say that Kenya has unique co-benefits for direct air capture, specifically from utilizing waste geothermal heat and electricity and sort of like infrastructure to lower the cost of electricity for everyone, including other industries, but also consumers, including those who are currently not on the grid, expanding the grid to them, cross-subsidizing electrification across Kenya. So it's an exciting backdrop to our work, and I think really we want to talk a lot more about like what it actually looks like. Again, we've shown these slides plenty of times, basically. Now, increasingly, it's time to show pictures, because again, that's essentially what DAC needs today: real building, real learning in the field, and we're proud to sort of have created some of that. Before we do, I'll very quickly hand over to Duncan to touch on some cornerstones of our technology, and then from there we'll dive straight into our project learnings with me riffing a bit on top of those. So yeah, over to you, Duncan.
Right. Hey, everyone. Very excited to be back. My name is Duncan Kariuki. As mentioned earlier, I focus primarily on the engineering and the project side of our technology. And at Octavia, basically, we will set out to develop a geothermal integrated DAC with a very clear understanding that DAC is energy intensive. We focus primarily on integrating DAC with the lowest cost and most abundant and cleanest form of heat. And in that case, that for us, that's geothermal, of which we have plenty here in Kenya. And so everything that we have developed has been really geared towards that and deploying it at really low cost. We focus primarily on three aspects of the technology. That's the material science, some of the process engineering around that material science, and then also some of the reactor engineering and manufacturing, as we'll see in a bit. So our process is it's fully patented, particularly the chemistry and process engineering. We focus also on stabilizing materials, and our process itself is called a thermal vacuum swing approach. So with the way we swing the capture and release of CO2 is using we swing it by changing the pressure and elevating the temperatures within our reactors. So what you're seeing here is one of the reactors or machines or units. Inside there is packed with a material that is highly selective to CO2, and then everything around it is what we call the balance of plant that allows it to operate. And now this is actually the unit that we've deployed in the field. But before we go into the field and some of the learnings that we've had, in the next slide, we'll see some of the iterations that we've had in our technology. And the thing here to really stress is that our DAC is really early stage technology, and so it needs a lot of iteration to really focus on optimizing for both the cost and the operational efficiency. So we've cycled through different designs, different materials, as you see here. So here, what you're seeing is a manifestation of, or at least the different reactor designs and form factors to really operationalize DAC. And we've taken all these different shapes, and each has taught us something new that has allowed us to improve the next unit. We finally got to a steady state at some point last year and used that to deploy in a pilot plant as our Gen 1 technology, which we're going to see in a bit. And that takes the form factor of the cylinder, as you can see on the foreground here. And that one is just really geared towards optimizing the operation of the process in a very safe and reliable way, particularly when thinking about dealing with vacuums. So we'll now cycle through quickly in terms discussing our journey on developing our project, or at least our pilot project. The primary objective of the project was to get our technology out of the lab, out of development, and into the field where we can get real-world data, and at the same time validate the end-to-end process for developing a project as well as validating all of the costs. So we started out the pilot plant construction in August. The site, we relied on our storage partner for the site selection, when they selected an amazing site where there's plenty of access to geothermal energy, and then on top of that, very suitable geology for storage, and it's quite an accessible site. So we're essentially 3 miles from where their operations are located, and we started out with a small scale plant, started the construction in August. For this project, given that it was our first project in the field, we approached it more of a design build approach, where we did all the engineering designs internally. We worked with some external folks to review those designs, and then we subcontracted most of the construction, particularly the civil works and the electrical transmission. And then for the actual integration of our technology with its balance of plant, we did that ourselves. And that is different from how you typically do a plant like this, given that this is a pilot project. We optimize for speed more than anything, and our ability to validate and bring a lot of the learnings with developing a project in-house. So the entire process took us about 6 months to get from design to final commissioning. So we started the designs in June, and then we commissioned the first reactor in November, and everything else was finally commissioned earlier this year at the start of January. So that's the construction phase of the project. There are many learnings that we'll just walk through as we go through it. And as we go to the next slide, one of the other things that we really wanted to do in this project is really take learnings from other industries and transfer those into our own technology, because DAC, when deployed in a pilot plant, is really an infrastructure play. So one of the things that we really focused on doing is doing a lot of the balance of plant integration in-house as well, and breaking it down into a very modularized system. And that was super helpful for us, as it allowed us to really go through, minimize work on site. And as we know, infrastructure projects face problems with cost overruns and timeline overruns if there's a lot of work to be done on site, because there are a lot of uncontrollable conditions there. And we experienced that ourselves in the early days. So we worked to do a lot of that work in-house, do a lot of the prefabrication in-house, as you'll see on the next slide. And that also allowed us to do a lot of the testing in-house with our team, and front load a lot of the things that we want, were first of a kind for us, or at least it was the first time doing a full balance of plant integration with our technology. So that was super helpful, and it allowed us to also front load a lot of these things. There were some failures, and we'll discuss some of the challenges, especially with going through this design build approach, as well as choosing to do a lot of the work internally. It does present certain challenges, but I'll pause here and just invite Martin in case there's anything he has to add before we go into the subsequent phases of the project.
Yeah, no, it is definitely a point of pride that this plant has come together very quickly, in 6 months or so, and we're proud to say that it finished on budget, and on time. I think one learning that we definitely did sort of like have is that the sort of like EPC selection and site preparation is not to be underestimated. And I think especially when deploying at a site that is new to DAC infrastructure, basically, and also as a company that is new to DAC infrastructure, I think that is where we had the most delays. And I think we got delayed almost by 2 months at the start of that project due to sort of like site challenges, basically, and then had to catch up very quickly, sort of like towards the end of that sort of 6-month period, basically, having a very strict sort of end of year deadline, and then sort of like catching up at that point. But that sort of did come definitely like at a cost to the teams. I think there was definitely like a lot of like learnings that we had, so like from doing the prefabrication in sort of in-house, basically, and that's just in a controlled environment. But like everything to do with the site, I think we did learn is like definitely something that invites delays, basically. And I think in that sense, like sort of having a site that you sort of select and sort of like choose to scale to a very large scale, and that makes a big difference. But yeah, thanks so much. Back over to you guys.
All right, thank you. So yeah, and as Martin has mentioned, it was especially on site. While one of the biggest learnings is just dealing with the different weather conditions. We're quite lucky where we are in Kenya. We have very stable weather conditions throughout the year, but the place where we selected, we had unimaginably high wind speeds that really were moving very tall structures. And so those were some of the things that front-loading this allowed us to make modifications to the design of the plant and allowed us to pivot very quickly on a lot of the things. So as we head to the next slide, now we went from doing the prefabrication in-house, the assembly, all the pre-commissioning or cold commissioning, as we call it internally. And then now the next challenge was how do we get all of this to site and then install everything and do that relatively quickly. And the logistics of this whole process were quite challenging, particularly because it's quite a remote area, and the roads to get there are very, they're not tarmac, so it's a marram road, so you have a lot of vibrations, and that presented a lot of challenges for us on the equipment. So we assemble something in our facility and get to site and half the bolts are gone, for example. So that was a big challenge that we had to overcome. We recovered towards the end, and especially with very sensitive equipment like our reactors, as you see them here, and changed how we fabricate everything. So that meant that we also had to install or build specialized equipment just to support and hold the sensitive equipment, just to be able to handle the logistics to that area. And now, once we got there, we began the process of that balance of plant integration, as you can see on the next slide. And it is a very intense process because we're essentially working from different sections of the plant and then working to integrate all these different sections and make them work with each other. And any one piece can go wrong and cause a problem in the commissioning step. And so during the balance of plant integration, one of the things that we learned when we did the cold commissioning in our manufacturing facility, we actually found that there were because of the speed at which we moved, there were areas where we ended up having failures in terms of like wrongful termination of valves or instruments, and that ended up causing a lot of delays in the commissioning process. And so one of the things that we learned and took to the field when we started the balance of plant integration is to actually detail and really document with a lot of rigor the entire installation, the entire quality control, and the commissioning processes. And that really helped us. And we'll also discuss how one of the things that made a major difference in the field, but it really helped us move in the commissioning much faster. So all in all, installation, commissioning of everything took about 3 weeks, right from just bringing the first piece of equipment to having the plant running. And that included pressure testing and pressurizing all the lines and getting them into operating condition. And on the next slide, now we start to get into the operations of the actual plant. And one of the things that we've also learned and has been a big challenge for us is the repairs and maintenance of at least our technology in the field. These are very heavy units, and initially, as we designed them, as you can see them there, the reactors are on caster wheels, so they're designed to be allowed to move. And one of the things that we've actually found to be a challenge in maintaining a high plant uptime is the amount of time it takes for us to be able to disconnect any reactor from the plant, get it to a crane. We have a fixed crane there that allows us to maintain everything and open everything up, and then reconnect that back to the plant. And so that has typically taken us a long time for that turnaround, and we're working on ways of improving that, but it's also something that affects the plant uptime and has been a challenge for us, but we are also finding ways of improving that. Before we get to the next slide, I'll also invite Martin again in case he has anything to add on the topics I've just discussed.
No, thanks. And I think, again, like we know from, again, how admirably transparent Climeworks has been about many of their challenges in Iceland is that, like, again, like most DAC companies, when they sort of first built their techno-economic models, they would sort of like, assume maybe like an, 80% capacity factor, like, like thereabouts. getting there is hard. You start out and like many things don't quite work as you want them to. So like building your plant and building your facility like for ease of maintenance and repair is incredibly crucial to get to like a steady state where you can have those uptimes basically. Because much as you might test your machine inside your facilities, the field will throw challenges at you that you do not expect basically. Again, like humidity conditions, like wind levels, and like temperature, like many aspects that you do not quite sort of expect. Plus, I think again, it's also important to say that like DAC by its nature, pretty much again, like there's some replicable processes in direct air capture. Right? Like you first expose like a solvent or like some sort of solvent, like some CO2 reacting molecule to air, and again that part is sort of straightforward enough. But then to release that CO2, it generally like involves like some amount of like heat, pressure, humidity, some mix of those. And that always also tends to mean that like operating those in the field in sort of unknown conditions tends to like also like lead to sort of sensor failures. It tends to lead to like bad visibility of what's actually going on in the in your machine. Basically, it tends to mean that you have to open the machine quite often to actually see, okay, what actually happened just now, like what actually happened here, etc., etc., etc. And then if something fails, again, like having some sort of like speed to repair, so like the mean time to failure and the mean time to repair is incredibly important metrics, basically, as you want to get a direct air capture plant to steady state. And it takes work. Again, like I think the idea that everyone would love, of course, is like to just plunk down a DAC machine in like a new field, and then yeah, it runs like 24/7, easy peasy. But that is just not where DAC is today, and I think that's incredibly important to say. And again, I think for us, again, in the logistics of bringing like component parts and like the experts basically between like Nairobi and like field facilities has been quite a challenge basically. So like planning for downtime and planning for so like ease of repair and ease of maintenance, and having some sort of like predictive maintenance schedule that you sort of very actively work on and sort of like keep alive as a live document is quite important basically. But again, I think in DAC, yes, I mean, we should sort of like obviously plan for success, but also plan for failure, basically, right? Because failure is an important part of how we get DAC to maturity. And I think, again, in that sense, it's very important to just have the sort of like the components, the experts, and the sort of procedures on hand to actually just make sure you get your machine, you get your plant very quickly to those uptimes as well. Thanks. Back over to you, Duncan.
Yeah, thanks for that, Martin. And now, once we've gotten the plant, we've to the field, we've assembled it, we've commissioned it, and now we start operating it. There's the ramp up phase, and this is the phase within the commissioning period, or when the commissioning period ends, that we are actually in right now. And in this phase, we're basically looking at getting to the plant to its design capacity, and on top of that, getting it to produce at a level of consistency that we need. For any large-scale plant, whether it's a chemical plant or a direct air capture plant for this of this type, there will be that ramp-up phase. And this ramp-up phase is extremely important, as it's given us a lot of learnings in terms of how we design our technology, the engineering design. Our material science team and our R&D team are also really focused on getting those field learnings as well, as they're letting us know how our sorbent is performing in very humid conditions, getting up to 95% humidity at night. You've seen we are quite near a lake. And this, an example of one of the biggest challenges we faced we faced in the ramp-up phase, thankfully we've now mostly solved it, was getting purities consistently, high CO2 purities consistently, because we are getting the DAC process is essentially getting CO2 from a very low concentration of 0.04% thereabouts, and we want to get that to over 99% concentration, so for us to liquefy the CO2 and store it. And that process in itself, if there's any leak anywhere in the system, then we're not getting that purity. And we've had to work through weekends to get to a point where we've eliminated all leakages in the system to get the purities as high as possible. And those are just some of the challenges we've had to really overcome within the ramp-up phase of the project. And then on top of that, just getting the mass flows to wherever we need them. And then on the next slide, one of the other things that was really important for us, both from a construction and an operational standpoint, is the occupational safety and health. We did have one minor incident during some maintenance activities where one of my colleagues fell down and ended up spraining his wrist. He's okay right now, but in any construction project, in any plant, occupational safety and health, and we're quite lucky that our board members and one of our board members and our investor has built large-scale facilities like this before, and so he's always giving us a lot of guidance on this. But one of the things that has been a proud success from this entire project is the level of detail in which that we took that safety aspect, where everyone, and we have a daily safety briefing on site, where we discuss whenever there are any incidents and how we are learning from them. And so we've had that continuous learning and approach for our facility. And even with that incident where one of my colleagues sprained his hand, we took that and had a very long discussion about it to see how we can improve our operations. Now, one of the other things that's pretty interesting about and unique to this particular facility, as you'll see on the next slide, is we're in a very wildlife-rich area. And so we've had all manner of wildlife visiting us, paying us a visit. During the construction, as we're passing an underground cable, we had a massive python because we're digging trenches, and we had a massive python that we just uncovered from its trench. We've had hyenas visit our site almost every night. Before we even put up a fence, we just had 2 containers there. We had some leopards visit us. And this has been, it's a new experience to us. We manufacture in Nairobi and not a lot of wildlife wherever we are. Of course, in Kenya, we see a lot of this wildlife and we grow up loving and cherishing them. But doesn't make it any easier to come face to face with the hyena, as you can see here. So we've also had to get some external training from the Kenya Wildlife Service. And one of the things that Kenya, or at least my country Kenya, has been really good at is being able to build infrastructure or at least in wildlife areas with minimal impact to surrounding wildlife. You may or may not know that Kenya's largest geothermal field is smack in the middle of a national park, and there are a lot of lessons that the state-owned enterprise that built that field or developed that field and built the power plant there. There are a lot of lessons that they took and have applied in that project that we've also borrowed from. So one of the most important things, if you're building in Kenya, do some wildlife training, which we were able to do. And I'll circle back now to the team. I mentioned earlier during the installation phase, one of the biggest challenges that we had, especially when we did a pre-commissioning in our facility, our manufacturing facility, is we were pretty short on human capacity because we're doing it ourselves, and we ended up having to stay till odd hours of the night, working 16-hour days, just to be able to get everything assembled, and then we didn't do it properly and had to redo a lot of the work. So that cost us a lot of time and contributed to the earlier delay that Martin had talked about. So one of the things when we went to the field is we put team capacity at the forefront. And one of the things that we did is we have an EPC partner who helped us in the civil works, especially, and they seconded a lot of their people to us, so welders, technicians, fitters, electricians, and that gave us more hands. And when we're doing the installation in that 3-week period, we had about 40 to 50 people working full-time on site, and we moved really fast as a result, and we're able to be really well coordinated. But even beyond that, we've had between 22 and 24 Octavians on site. Some of the other people who are working with were seconded to us by our EPC partner. But we've had Octavians on site. So, and one of the other things that we've had to really think about is how do you accommodate that large number of people in a remote area? How do you make sure everyone is safe? How do you make sure everyone is, even in a high stress environment, a very hot area, that everyone's well-being is really well taken care of? And we have a great team, HR team, that spent a lot of time doing that, including finding flats in one afternoon, 6 different flats in one afternoon, which was, they were very stressed by that, but it was a massive delivery from them. And obviously, once you have the team on site, you have to get them to site somehow. So this is just a fun picture of us huddling together in a van just to get from our apartments to site on a daily basis, every day and heading back. So I'll pause there and then I'll invite Martin to add anything that I might have missed. But building this project has been a massive success for us. We're really proud of it, and we'll continue improving the technology and sharing whatever other learnings we have after operating for another 3,000 or 5,000 hours, just to ensure that we are learning collectively as an ecosystem.
Mm. And again, like I think the people that you see in this picture is really what has enabled our fast progress. I think that's often being remarked on, again, that like 2.5 years ago, like DAC in Kenya was a crazy idea. And again, like now this is like, in the process of building this plant, we have created somewhere upwards of 115 temporary jobs, and we've touched that many lives in our community up to date, basically. We sort of like about 1/10 of our team at this point is like fully comprised from like local stakeholders, basically, like that we sort of onboarded, that we're upskilling, doing apprenticeships with, etc. And ultimately, we've sort of really taken root in our community, and I think that's something that we're definitely quite proud about. Now, I'll talk a bit more about that. I think one note, just quickly harking back to CO2 purities, don't underestimate it. It is like nightmarishly hard. I think again the temptation is to think that you've built something at this scale and the purities aren't an issue. That's like, yeah, but I think like building large scale vacuum systems that are designed for like optimal airflow like most of the time, and then like tight vacuums the rest of the time, is very difficult. It's hard enough at the sort of level of a module, like, and you'll see that our modules are cylindrical, quite uniquely in the DAC space, partly because again most DAC machines are pressure vessels today, and again for pressure vessels that form factor does make a lot of sense. But then also really worth stressing that like you're not just building machines, you're building a plant, and the balance of plant in particular, having like like tens or hundreds of meters of pipes basically that run around a plant, and so like integrating all this into one large vacuum system is devilishly hard and not to be underestimated. And again, I think especially like building like projects like this for the first time, basically, there's a lot of best practice that needs to be learned. You might think again, and this is so that's definitely something that we've done, that you just get just like leak like sonographic leak detector, etc., and like the problem is solved. But no, like quite often like what it actually took is Duncan, and so again, as we said, like 20 people or so from our team actually like going out there on a weekend, like there's buckets of soapy water, like pressurizing the system and like finding the bubbles that pop up. Basically, a lot of this really does come down to elbow grease, and I think in that sense we're incredibly proud of this group of people that have really enabled us to move at the rate we did, being picked up at sunrise and sort of dropped off at sunset, or picked up at sunset, putting in the hours to really just allow us to have that sort of speed of iteration. And again, that's something that we're incredibly proud of. And I think just briefly, like the action note that I'll sort of say is on community engagement. Sort of like we're proud to sort of lead a number of community initiatives, and you can sort of like see that in our sort of recently published community engagement strategy. Again, we do deliberately put that out in the open. I do think that for direct air capture, for a number of reasons. Again, for one, because DAC machines tend to be black boxes, and so informed consent does get harder if you don't actually look inside what the machine looks like. For the reason that like DAC doesn't have inherent co-benefits, and for a number of other reasons that we specify there. We, as the sort of Global South's first DAC project, did see as a like unique responsibility in sort of getting that right, and sort of putting like ourselves and our strategy out there, and really like open for everyone to like critique and give feedback on, and ideally learn from. Really like taking that spirit of like learning out in the open. And yeah, I think again one thing that we're quite proud of is that we are at this point quite integrated into the community. The community tends to meet at the football field, or the soccer field, as you might call it in the US. And again, that is also like where one of our like initiatives was, and I think again potentially uniquely as a direct air capture company, we are sponsoring a football team. Maybe not quite the Premier League yet, but we're working our way up there. And so we are like incredibly proud to just like have added to the community in a number of ways, supporting so like everything from period poverty initiatives to like apprenticeships and upskilling people into actual like DAC livelihoods, and also like really like working with local stakeholders on the challenge that they see, things like water scarcity, things like infrastructure challenges, and again most of the time really like the topic of livelihoods and like supporting microentrepreneurship, etc. Lots of topics that have come up where really like we've gone in with sort of like a humble attitude, like listening, speaking to folks formally like dozens of times and informally much more often than that, to really just understand about like how can we actually integrate and benefit this sort of like setting that we're in, and the people in there. Again, the sort of logo on the football shirts is really just the tip of the iceberg, and we're proud to sort of be supporting the sustainable development of this community in a way that ultimately sees its future in DAC and the national development of Kenya also like as a key driver with DAC as well. So yeah, I should mention quickly that none of this would be possible without the amazing support of our buyers. I've put them here again. One that we're sort of particularly proud of that we've announced very recently was a deal with Carbon Future and Six. And Carbon Future specifically, we're also developing the world's first digital MRV system for direct air capture. The idea really being that ultimately we can count CO2 molecules, and you don't have to trust our numbers, but we can ultimately report them with a third party like Carbon Future to be fully bulletproof, compliance grade carbon removal, as we might call it. And so super proud to have that recent deal and many others that have sort of like bought from us, and again have ultimately unlocked all this work and the speed of progress that we've seen. Again, we would be nothing without all of you, and again Bjorn, and we sort of like owe a lot to you, so thanks for all the support through these early phases of our project. And with that, it remains to say thank you. Again, like not just to our buyers, but to everyone, Chris and the whole open air community. Like we've sort of like had so many touch points here. Again, I think ultimately we've been amazed over and over again by just the fact that like we are like a uniquely collaborative community that has helped out, and we've been proud to sort of like contribute in a number of ways, like open sourcing our early stage designs, but also like really like benefiting a lot from sort of like the mentorship of many people in this space, and the sort of incredible humility and an openness to share learnings and to really like advance the field, especially here in Kenya, where like the impact of doing so is just enormous. So thank you, and we look forward to your questions.
Excellent, fantastic! Wow, a lot of information there, which is fantastic. Well laid out. Really proud of what you guys have accomplished. We do have I got a few questions that I'd like to start off with, and I'll invite Tank to also if he has any questions of his own. And then we do have a couple questions coming in from folks in the audience. So please do add, and we'll try to get to as many of them as we can before the hour. I am going to get some of those football jerseys, Duncan. My children, my two sons only wear football jerseys. So got to get some of that swag. But let's start off with this. Our customary first question, which you guys answered in episode 79, is kind of where did this all come from, like your journeys? And I kind of want to ask it again, because I think, I am in touch with a lot of different, CDR companies, but there's something somewhat extraordinary by the rate at which you guys have evolved. It was 3 years ago, I think, Martin, where I was helping you fix your logo on a Canva, and you showed me a bunch of pictures now with like 60 employees, out in the middle building this, and so I've never seen anything that's moved so fast. And that, when I visited you a year ago or so, just this big warehouse, it's full of people working, it seems like around the clock. So could you give us a sort of a condensed version of how that happened in that way? And is there something unique to the context you're working in that explains it?
No, great point. And I would say in many ways it is the urgency of climate change, and also the size of the opportunity of DAC in Kenya, basically. I think that motivates us. I think ultimately we see that there is sort of like a big industry emerging here, basically, that Kenya can be a leader in. And it's not even just DAC, it is like an entire CDR industry that has evolved like from very little into like an actual like large like national sort of community at this point, basically, where we recently launched the Carbon Removal Kenya Association. And I think it really is like, I think that sort of like acknowledgement that there is sort of like big opportunity here for Kenya, which has traditionally been thought of as a climate victim, but very much so like doesn't sort of like intend to stay in that role, and very much like wants to sort of contribute solutions to the global conversation. And I think in that sense, we are just seeing that like ultimately what CDR and what DAC needs is just like lots of like energy and time and brains and hands, and ultimately the fact that we sort of like have a very young and dynamic and energetic population of extremely hardworking Kenyans has really meant that we have been able to move at the rate at which we have. It's not just the number of people; it's the number of hours they each put in. It's the number of the hundreds of thousands of hours of R&D that went into developing a solvent from nothing that sort of really enabled us to be where we are today. And I think ultimately, I think there's a lot of things that come together here. I think not at least the understanding from our sort of buyers and marketing partners to understand that DAC is uniquely impactful and impacted by Kenya also in terms of coming down the cost curve, that has enabled the speed of progress. I'll let Duncan sort of comment a bit on maybe his and journey and that of our engineering trajectory and how we've sort of moved so fast in that front. Basically, it has to do with a lot of failing, and I think we just tend to be quite humble about that. It is part of how we actually bring DAC down the cost curve. And we have come a very long way. I mean, one point that I was going to make that we were proud of saying that we've now deployed 4 modules at the site, basically. The first one that we built costs about twice as much as the last one that we've built, basically. That is the learning rates that we've had. And the last one is a better machine too, which is the slight irony here. There's lots of elements of material selection, design, supplier selection, economies of scale, and so on, all of which are incredibly impactful. And again, that speed of learning is not just there in the size of our team, it's ultimately there in the sort of levelized cost per of DAC that we still have to do a lot to actually get to a point where it's ready for the mass market, but that is the urgency that we have.
Yeah, but Duncan comes in with his is, I should just say a remarkable measure of that is I met Duncan when he was finishing up his undergraduate degree and was looking at doing a project on DAC and talking to him, and now he's emerged as this true titan of the field, not just in terms of his technical leadership, but his ability to tell the story about what they're doing on the biggest stages, from a COP to a UN Climate Week. So when I think of the transformation, I think you are the mascot for that, Duncan, and just in terms of how you've been unleashed. But yeah, if you could share a little bit just about looking in the rearview mirror, whoa, where are you right now? How did this happen?
Yeah, and thank you for that, Chris. It was just 2021 when we met on the Open Air Collective. So yeah, it's been quite a journey since. I think for us in Kenya, climate change, we see it every day. My own parents are farmers. I've seen it with them. A lot of my colleagues have the similar experiences where the problem that we're solving is quite visible to us. And now put an engineer in the same room with a problem and you get a 60, 70 hour work week. So we have all these folks who are incessantly focused on solving the greatest problem of our time with a clear understanding that it's going to be challenging, it's going to be hard. And we have everyone is extremely motivated towards solving this problem, both from a technical standpoint, from a project standpoint, and ultimately also from a commercial standpoint. That's been the biggest motivation for us. And what really helps us is, or keeps us going is, in as much as there are always those challenges and failures that we incur in the entire development process, the wins, they're just massive wins in our sales. So they always keep us going, and we are always really proud of every little thing. Even when we hit 100% purity, we had a massive celebration in the field, and because it was after weeks of work, so it was really something for all of us to be proud of, and that got us onto the next challenge to solve, because they never end.
Great. Well, I have a couple of other questions, and then we do have some good questions from Narasimha and Amir. And Tank, feel free to hop in. I do want to talk a tiny bit about community engagement from a kind of a on-the-ground perspective in terms of what that has actually been like, the types of people that live in the vicinity and the kinds of questions and things that they bring up. But before I do that, you did mention, Martin, and I just think it's really impressive. There's these hot spots of sort of CDR ecosystem building and enthusiasm that all have their own sort of composition and, arguments that they kind of make. And Kenya is really right up there in pretty small company, I think, in terms of the vitality of the broader CDR sector. You talked about it a little bit, but I was wondering if you could give a little bit more sort of color to what that's like, and maybe even refer to the recently formed Carbon Removal Kenya, which I know you guys are a big part of.
No, absolutely. And it's worth noting that we're sort of like standing on the shoulders of giants. And Kenya has very long been a leader in conservation, arguably since its independence. And again, we're the global headquarters of the United Nations Environmental Program. We're sort of like home, like proudly to Dr. Wangari Maathai, who was a Peace Nobel laureate for her environmental activism as well. And that is sort of like the stories that sort of Kenyans grew up with, sort of like from their school days, basically. So like a lot of this is genuine here. It also means that like before even car removal, became a more force in Kenya. Kenya was already the largest issuer of carbon credits in the conventional space on between like African countries, basically. So definitely like there's a very strong ecosystem around here. I do think that. That sort of has given rise to like a very strong sort of like a carbon removal space as well, where I think that sort of like ideas sort of like are tested and sort of like get sort of like examined and sort of like tried and again and sometimes like fail very quickly, basically. And I think Kenya is just like for one, I mean, a crossroads for talent from all over the world, basically. So I think that also means that like there's an openness to ideas that sort of like means that sort of like CDR has flourished uniquely quickly here in Kenya. I think there's like a sophistication of our government stakeholders about how to regulate this sector and how to really like understand and how to engage with the sort of local stakeholders. But just again, there's also some challenges there between like the sort of questions about like how sort of like carbon removal should sort of contribute towards the national treasury. But overall, I would say that that has sort of given rise to like an incredibly strong carbon removal Kenya association. I think we're now up to somewhere in the space of like 15 to 20 or so members. And again, I think we are now also home to the Africa Carbon Removal Accelerator here in Nairobi, which again is really taking that to like dialing up that to 11 basically, much as it is a Pan-African accelerator. Again, like being based in Nairobi very much reflects the vitality of a local ecosystem. And yeah, I think that having like the sort of first national carbon removal association in Africa definitely also reflects that sort of energy. And for anyone interested, again, there's going to be an official launch event sort of coming up soon in April. Sort of be on the lookout for that for our local Region 44 screening, alongside the launch of the Africa Carbon Removal Accelerator and the Carbon Removal Kenya Association. Super excited that like this is really like becoming such a force. And again, we want this to be like a major contributor to Kenya's economy, for it, allowing it to like really develop in a sort of like carbon negative and sustainable fashion, and creating livelihoods and really like just creating impact. The one thing I'll say very quickly again, because this links to like what I was just saying, is that you asked about the community engagement. There's a lot that could be said there. Again, we did just publish a 40-page like strategy about this. It really like gives the full detail about the sometimes problematic history of community engagement. From Kenya historically, also like into like some local carbon projects and some local geothermal projects, and some cases where it's been done very well, for example, in like local wind energy projects, but really like looking closely into what that means for us, and like how we've sort of approached this space with a lot of humility and like a lot of learning, and also like just real sort of like contributions in hand, basically, right? Like just showing up with promises doesn't sort of like cut it. And so the number one thing that comes up is livelihoods. So again, and I think that's really important to say, Kenya has sort of like a very well educated young population, but it generally enters a job market that is extremely tight. And even in Kenya, we are sort of like in Octavia, we're sort of proud to attract some of the best engineers in the country. But our sort of number one competition is actually emigration, basically people going elsewhere to sort of like the foreign degrees, foreign on scholarships and so on, and then just like going elsewhere to sort of find a fortune. In that sense, like it's something that we're incredibly proud of, to like really provide like the hardest engineering challenge, well, one of the hardest to work on. I think Duncan quite likes to joke that after the fusion folks, it's basically us in direct air capture, because it is a hard engineering challenge. And so again, ultimately, like that has to translate into livelihoods to have a real impact. But certainly, I'll leave it there.
Great. And I see Duncan, I know he's got a little bit of a power fluctuation where he's sitting right now, so hopefully he can answer this. Tank, why don't we get to the two questions that were asked there? Feel free to tag on any of your own. I'm sure you have thoughts.
Yeah, well, I think we'll answer these audience questions here. So the first one here is about evaluating the efficacy or the efficiency of the capture process. So can you speak about that?
I can definitely, and thanks again. Like, again, there is like, just to be clear, like this is like their carbon capture and storage, and maybe less is like the traditional like point source carbon capture and storage that is often like abbreviated as CCUS. I think the way that we evaluate the efficiency, ultimately what it comes down to is just like dollars per ton, right? Like that is the number one metric that matters in this space, is because DAC is expensive today and it cannot be if we are to scale. And so currently, again, like the sort of like costs that we see are sort of like in the sort of high hundreds of dollars per ton, basically. And the goal very much for us now is to bring it to the low hundreds of dollars per ton, basically, and to do so soon. Again, there's like sort of like elements of techno-economics that go into this. There's like then that's everything related with like the project, the technology itself, basically the scale at which you operate, the cost of the energy that sort of like feeds your project, all have sort of like a role to play there, basically. There's of course like the sort of like at the more sort of like granular scale, you might look at the sort of like carbon capture efficiency of your solvent, basically, and so like its capture capacity specifically, and so like that's the key metric that you want to optimize over time. Your cyclic capacity, how many cycles you're able to do on that solvent, and then your like wider DAC system, etc. There's a number of ways to look at that. Ultimately, what it all boils down to is cost. Basically, it's cost that has to come down with DAC. We cannot expect to scale at the cost that we are today.
Thank you. Yeah, that's great. So the second answer, the second question, I think you touched on the talent that Kenya has and the legacy behind climate actions, and I think this question speaks to more about the geography, right? Can you give us more details on what makes Kenya unique in terms of for direct air capture, and particularly for the sequestration part of it?
Yes. So again, as I mentioned earlier, the sequestration is ultimately done by our CO2 storage partners, Sela Mineral Storage, and we sort of generally still refer folks to their successful Frontier pre-purchase application from 2022 as still sort of like the best source of like information on their general approach that is publicly accessible. So I can't speak to any details about their technology and their project. What I can say is that like the capacity of storage in Kenya is enormous. Even just for, again, like the sort of specific area we're looking at, like we're talking like gigatons of CO2 storage capacity, which is generally the case with CO2 storage. Again, the sort of the rule of thumb is that if you can capture it, you can store it, at least so like once that storage is up and running. And of course, that is a key challenge in many geographies. But the capacity is definitely there. Broadly speaking, the sort of the target geology for us is basalts, specifically flood basalts, but that's pretty much where my sort of very amateurish geology knowledge ends. We're very much more on the sort of like engineering side, on the direct air capture side of things. But again, like worth shouting out Sela as doing excellent work on the storage side, and again being just one of only 3 like CO2 mineralization projects in the world today. Very much sort of building on top of like Kenya's successful legacy of having a geothermal sector that has good experience and know-how of that subsurface drilling and like reinjection of fluids, etc. So yeah, I think really just building on the history that we have in this country.
Billions of tons, it sounds like, just in the basalt area. And to give you a perspective, like 10 billion is sort of the upper limit of what people think we need by 2050 globally in terms of CDR. But
yeah. And again, I think it's worth saying that again, like there's like, as far as we know, I think there's close to like 9,000 sort of cubic kilometers of the right geology. It's just like vast amounts of pore space for CO2, basically. So likely in Kenya and potentially the broader East African Rift Valley, there's ample sort of like both energy and geology to store all of humanity's cumulative carbon emissions. The number one challenge that there is now is that like nobody knows how to build DAC cost effectively at scale, and that is the exact challenge that we're cracking, and where we think East Africa has a unique opportunity to do that.
Great. Well, we are at time and we could absolutely speak a lot more. But what I'm going to say, Martin, let's just do an annual commitment to have you guys on the show, unless some other major breakthrough happens, which you guys are routinely making. If there's some news to make or whatever, you can hop on anytime. But absolutely thrilled to see your progress, and your willingness to show your progress is in and of itself, I think, a testament to the values that Octavia is built on. So say hi to the whole team for me, and we'll see you back, and keep up the great work. All right.
Thanks to you, and thanks for everyone working in the space.
Great. All right. So I am going to just very quickly give you a little overview of what we got coming up. Next week, we're really excited to have our friend Alexi Denard from Carbon Gap, the premier CDR policy and advocacy organization in Europe, is going to come and kind of give us an overview of the very rapidly evolving policy landscape in Europe, both at the EU level, the member level, and the municipal level. And he's going to do that by actually featuring their recently relaunched, as of last month, policy tracker, which is an excellent tool. Lexi's a real wonk, but he knows how to talk about this stuff really clearly. So if you have an interest in CDR policy generally, or if you, particularly in Europe, this is definitely a show you're not going to want to miss. And then following that, we're going to have our friends at Mass Reforestation, who do forest-based removals, but have kind of an interesting approach to it that they'll get into, and they'll talk about it. And then following that, we will have a couple that we're not quite sure which date, but we've got the next several lined up, including the policy one that I mentioned, a state policy preview here in the US, some on open source MRV protocol development, which is quite interesting, and then a really exciting local government CDR purchasing challenge that I'm getting off the ground through the Four Corners Carbon Coalition. So a lot coming up this spring, but really want to thank everybody for joining us today, and hopefully we'll see you next week. Thanks, everybody. Bye.